Right, well, good evening, everybody. It's fallen upon my narrow shoulders to welcome you all to the meeting tonight, those in attendance in the room and those online. So hope you managed to keep warm. Okay, we'll keep the formalities to an absolute minimum. It's my pleasure tonight to introduce Richard, VK3ZCL. Yep. I nearly put it wrong. Sorry, Richard. But Richard's going to talk to us about homebrew power supplies, case and power distribution boards project he's been working on. So, Richard, without further ado, the floor is all yours. Thank you.
Thank you. Okay, so my name's Richard Gibbs, call sign VK3ZCL, and I'm going to talk about homebrew power supply case that I made, which is sitting up here, and the power distribution board for the case. Okay, so I thought we'd just go through a brief agenda to kick things off. So I'm going to talk about the motivation for this particular project, designing and building the case itself, all the metalwork, designing and building the power distribution board and making that, procuring that, putting it all together, and then some final tips and takeaways, some of the lessons I learnt as I worked through the project. Okay, so motivation for the project. Why am I doing this? Why am I building this? So I had I still do have a Yaesu FT818 that I was operating barefoot for quite a while, sometimes with the internal battery, works pretty well, and sometimes with my old mini base 13.8 volt Plessey power supply, which is sort of exceptionally old, possibly older than I am, and I'm reasonably old. So, but it worked well. But then I acquired a 2 metre amplifier, which is do 50 watts. It's a Yaesu FL2050. And the combination of the radio and the amplifier, just the power supply couldn't, give enough current. It's only good for about 4 or 5 amps. So it was time to do something new and get another power supply basically with a bit more capacity. So being a dutiful amateur, I pick up lots of good things at hamfests and radio conventions. My wife would call it junk, but I call it good things. And some of these things I use straight away. Some may sit around for years or possibly even decades, but they're probably going to get used one day. So this particular power supply module, which is in my power supply, is a Hewlett-Packard HP PS3702C, and it's a 12 volt, 60 amp power supply. And I picked that up at Gipstech quite a few years ago. A guy was selling them and they were pretty cheap. I think $45 or $50, which is very cheap for that kind of power supply. It came originally from a server type, a computer server room, I think, some kind of rack installation. So it was designed to slot into a big rack for redundancy, I'd imagine. So, you can pull them, not all of them, but perhaps one or two in or out without the network going down or the server going down. So at the front, or it would have been perhaps at the back, depending on how it was originally arranged, there's a mains, just a mains IEC socket. You can see there in a handle for pulling the unit in and out. And at the other end, there's an exposed set of terminals on some pretty decent circuit board for the 12 volts and a couple of auxiliary connections too. So I thought, great, I'm going to finally use this thing. It's been gathering dust on my shelf for years and put it into a power supply. This is good. It's also very light. Despite the current capacity, it's a switch mode supply and it weighs probably only 1 kilo or 2. It's exceptionally light for the capacity, so it's really good. I liked it as well because the mains was all enclosed, so I didn't have to mess about doing mains wiring. I mean, I'm happy to do it, but if you don't have to, it's always better not to. But of course, there's a bit of a problem. There's enough energy basically to do a bit of welding, on those terminals. It's pretty dangerous. So I thought we'd just have a sort of a think about that last point I made. I think, as amateurs, we've really got a duty of care in terms of safety, both to ourselves and our fellow hams, to our family and, to members of the public. And whether that means, you know, you're talking about a power supply or high voltage or an antenna, I think, you know, we've got to be careful and respectful of each other and, you know, ourselves as well. So I thought, you know, we've got to make this thing safe. So I had to, you know, think about an enclosure to put it in, so I didn't end up shorting terminals or doing something silly and, yeah, having molten copper everywhere or vaporising tools. So that was the motivation for building and designing the case. So I had a few initial ideas or things I looked at, but I really couldn't find anything that housed it in the way I wanted. Some came close, but you know, they were sort of potentially big rack mount solutions, just things too big compared to the size of the power supply. So I thought, right, it's time to build it myself, I think. Get something made that's going to suit my exact purpose. So I cogitated on this for a little while and thought, and then after a bit of thinking, I thought, well, I'm going to build it and I'm going to sit it on a 10mm aluminium plate base. And that sounds quite thick, but it actually, being aluminium, it's fairly light. If it was steel, it'd be a completely different story, but aluminium's pretty light. And it's something in my professional field. I'm an electronics engineer, work for a company that does medical instruments, and we build quite large instruments, and small too, but you know, sometimes they're as large as a table, and often we use thick aluminium for bases, and it works really well. So I thought I'd use that for mounting the power supply with a bit of a bracket, and then I'd use folded sections of aluminium for the lid and the sides, and then just flat pieces of rectangular aluminium for the front and back. So fairly standard, I guess, but you know, all homemade. The other thing about the thick base was provided an easy way to hold the power supply in place, because you can see the picture there that there's a little tab or sort of L-shaped bracket hanging out of the back of the power supply. So I wanted something thick enough that I could just sit the power supply on without having to modify that bracket and potentially damage the power supply. So I thought I would do a bit of a template for this, mainly because, you know, I think it's easy to sometimes think, oh, this is easy, I'll just go get some metal or some aluminium and start hacking into it. But, you know, I find that's when Murphy creeps in, when you don't do quite enough planning. So I thought, I don't want to waste a lot of material, I'm going to build a bit of a template. So what I did was I got some cardboard from Officeworks, because I wanted it to be roughly the same thickness as the material. The sheet material is about 1mm, so I found some 0.9mm thick cardboard at Officeworks. Marked it all out and cut it, and I also made scores with a scalpel, just where I was going to do folds, so I could get some clean bends into the cardboard. And that worked reasonably well, and you know, I could visualise it, bend it up, and I took it to a friend of mine, Lance, who's helped me, or was going to help me bend it and fold it all up. And he could see straight away what I was trying to do, and sort of looked at it and went, yep, we can do that. So I think it's just a good way of getting it clear in your own head, but also if someone's helping you, making sure that what's in their head's the same as what's in your head, you know, so it sort of conveys an understanding of what you're trying to do. All right, so I got all the aluminium. I'm going to talk a little bit about where I source some of this stuff from as I go, in case anyone else wants to build things, because some of this stuff's easy to get, other things a bit trickier, and it's useful, I think, having the part numbers and things. So I got the aluminium from Aluminium Express up in Bayswater. The base plate is 5083 aluminium. The front and rear panels are just 2mm sheet, so a little bit thicker for rigidity. And then the lid is 1mm thick aluminium sheet. And it's originally in a 2400 by 1200 sheet. It's pretty big, but I got it cut down. Now, they were really good to deal with, and they actually cut the 10mm base plate for me. And they also cut down the front and rear panels, the 2mm material. So that made my life easy, and it was much quicker, because I don't really have the equipment to cut 10mm plate at home. And they also cut the big folder sheet down so I could get it into my car. It was actually a bit funny because I don't own a big car, I just got a little Toyota Echo. So I thought I'll just get that cut in half and that'll be fine. So I got it cut in half, go out to the car with my son, you know, go to put in a cargo. Oh no, it's still too big. So I had to quickly run back in before they shut, get them to cut the sheets in half again, and then I could get them in my car. But there's also another amusing story, I thought. I had my son there with me, who was about 9 at the time, and I said, Ollie, can you just hold the sheets against the car because it was a gusty day so they don't blow away? I want to go into the boot and grab a couple of things. So I go into the boot to grab some things, only in there about 30 seconds, come back out, and my son's gone. And like, this is in the middle of Bayswater industrial area on the road. I'm like, where's he gone? What the hell's happened here? And then I just looked over at the nature strip of the tree, and he's up the tree right next to the car, because it's obviously more fun, you know, climbing a tree than holding Dad's aluminium against the car. So it was a great relief when he appeared, and I was half sort of wanting to laugh and half wanting to whack him, but he was safe and sound and he was all right. But anyway, they were really helpful and good to deal with. So if you need some aluminium, recommend checking them out. Okay, so in terms of cutting and folding it, or going to the next step with the aluminium sheet, I marked it all out using the base plate. I just did it on the kitchen table. I had an old tablecloth there that was once white and hence has become pink, so I used that to protect the dining room table, and then just laid it all out. I found a metal ruler, long metal ruler, 1 metre metal ruler, really handy for marking it out, and just a rag or cotton bud with a bit of metho or IPA, just for rubbing out mistakes, and a good permanent marker. I also found when I was doing this that having a scrap bit of right angle aluminium there just to align the ruler and get everything square was really helpful. And again, that's not a special tool, it's just a bit of stuff I had laying around. So I cut the sheet, or Lance, my friend, helped me cut the sheet with an angle grinder, which I guess to some people may sound kind of rough, but he's a bit like a sculptor with an angle grinder. There's not a thing he can't do with it. He's really good. So he helped me do this. I think a few pointers there. It's really critical that you take your time and get it set up and jigged properly and nice and secure so it's safe. So we supported the aluminium sheet with a stiff bit of material, such as a bit of plywood or chipboard, and then just made sure it was well clamped down to the sawhorses, so everything was secure. We also used a bit of right angle steel, or again you can use aluminium, just to form a straight edge, especially for the longer cuts, so we could get them straight with the angle grinder. And then afterwards, just a matter of a bit of emery paper on the edge, and they came up well. And of course, again, just wear eye protection. Once I had got the sheet all cut out into shape, rather than drill holes in it later when it was bent, I thought it'd be a lot easier to do when it was flat. So I just marked the sheet when it was flat where I wanted the holes with the scribe, which is this device up here, and then just punched the holes with the auto punch, which is this tool down here, and then I just drilled 1mm pilot holes and 4mm holes after that, and got all that done, and that worked well. And just made sure again it was clamped down when you're drilling it. Okay, so in terms of folding it, again, got to clamp it down, at least half of it, to something firm. So again, a bit of plywood or chipboard, whatever you got handy. And then we also use a scrap bit of aluminium angle again to bend it. And then we had a bit of what I've called a bending aid, which is really just a thicker bit of material, something to give you a bit of purchase on while you're bending it. And having a good set of G-clamps is good, and various clamps. They're pretty cheap these days, so you can get them from Total Tools or the Big Green Sausage Shop, whatever you want. But there's plenty of them around. But make sure you've got a good set for doing this. And that's just a picture of us starting the bending process. So as we were going along, we found a rubber mallet was also pretty useful. to bend the material, particularly when you get right, you know, you sort of almost got it at 90 degrees and you just want to have a clean edge down where the bend is. You know, having that there's a good way to get that without marking or scoring the material. We bent the long edges first and then came back and did the interior bends. So you've got to think a bit about how it's all going to come together and try and fold it in a way that's easiest. For the interior bends, we used a scrap bit of 25 square mil aluminium section with 3 mil wall thickness, and that helped us do sort of the interior bends, and I actually cut that to the length of the case just for that job. So the intent was to use M4 button head cap screws, which have just got the Allen key slot in the head to secure the lid to the base. And you can see there, just an example of where I've done it in the corner there. It's been a long time since I'd tapped anything, so I thought I'm going to give it a go on a bit of scrap aluminium I had, bit of scrap 10mm plate. So I just clamped it in my vise and got the holes drilled and then tapped those, and yep, remembered how to tap again and thought, right, we're off and away. There's a bit of preparation for the tapping, so I thought I won't go through the whole rigmarole about tapping, but I want to go through a few points and things I learnt, I guess, along the way, and things I think others may find helpful if they're building a similar kind of case. So again, I marked the holes where I needed to tap with a scribe. I held the base plate in a vise, and then the vise was held up to the drill press, so a good vise, make sure everything's secure. And then I used a centre drill to actually start the holes. And that's the centre drill up there, and again I've got the Sutton part number, and you can just Google that if you want to get one of those. But yeah, they're really important, because if you don't use those, I've found that even when you use a punch, you know, drill bits can move and wander. So this just makes sure you get the hole exactly where you want it. I then drilled 1 mil pilot hole, followed by 2 mil hole, and finally the 3.3mm hole, which is what you need for tapping. Now, perhaps a 1 mil was a bit of overkill, but that's what I did. And one of the things I did too is made sure I had good sharp drill bits. So I bought new drill bits when I started doing this. They're not particularly expensive, so I think it's worth the investment. In terms of the drill speed, did a bit of Googling and found that you need reasonable speeds for aluminium. So the drill press I had access to's got a speed control, which is really nice. So I wound it up to about 3,000 RPM, and that worked really well. I found a small bit of lubricant is good. The combination really of the good drill bits, high speed, and the lubricant produced, good clean holes. So they were good for tapping. So the other thing I found useful was when I had it all set up. Unfortunately, I don't have a picture of it, the plate set up vertically in the vise, or in the drill press, but you can see the drill press has got a depth gauge on the side which you can adjust. So there's a stop at the top, and then this nut here can just be adjusted, and it comes down against this block here. So I used that and just sat a ruler basically up next to that, and I could get the heights adjusted. And the reason it was important is because I was actually in the corners anyway going to come in, in two directions. So I didn't want to go too deep and potentially end up colliding with another hole. So I found that was, using that depth gauge was really helpful. Now the guidance for tapping, I got out of a fantastic article by Drew Diamond from AR, and I've got the reference up there. If you haven't come across Drew Diamond's articles before, I'd really recommend, looking up what he's done. He's written some great articles, lots and lots, probably hundreds. And he's also a great technical illustrator, so he does everything by hand, and it's brilliant. It's really good. So certainly got good, inspiration from this project through his articles. One of the things I found was, everything's got to be really securely clamped while you're tapping. I also used a bit of Sutton, it's called Venom cutting fluid, which is a fancy name. There's lots of other cutting fluids. Singer sewing machine oil, I believe, works well. So you can use lots of things, but I happened to buy this because I didn't really have anything else. And the other key thing I found was as soon as you're sort of tapping, if it starts to feel raunchy or a bit crunchy, just to back it off. I did that, you know, whenever it didn't feel right, I just backed it off and then turned it again, and I found that worked well, and I didn't snap any taps. So I was pretty pleased with that. And again, there's advice from Drew in his article about that. So that's the box coming together with the base plate and the lid screwed down, and then you can just see the button head cap screwed into the side, and it's the same on the other side of the enclosure. So I sort of reached this point and I was pretty happy. It was coming along okay. The next step was to tap the hole in the other, or what is the back. That's this one here. So I did, similar sorts of thing. But when I did that, I found that the power supply was sort of held okay in one direction, back to front, but it would actually pivot about that point in the back of the supply. So I thought, well, this is going to move around and eventually it'll, break if I move the power supply about too much. So I decided I'd make a U-shaped bracket for the other end, just so it's basically held then in both planes. So for the bracket, I use the same 1mm thick aluminium sheet that I'd use for the lid, and I just cut a 1 centimetre wide strip and bend it up, just literally in a U shape. You can see according to the pictures there. This time another friend lent me his jigsaw, and I bought some fine metal blades, and that worked really well. It cut like butter. It was fantastic. But make sure you do it outside. I'd done it outside luckily, because it sprays aluminium absolutely everywhere and makes pretty horrific noise. So it's not a job to do in the lounge room. It's definitely an outside job. And then I just tapped 2 more holes in the base. So it's one there and one on the other side. And then again with M4 screws, and that just held the thing down, and once I did that, it was nice and secure. It was fine. Okay, so on the front panel, which was a 2mm sheet I talked about earlier from Aluminium Express, I just wanted a power indicator, which I'll talk about in a little bit. It comes from the power distribution board, and a switch. Now this switch, excuse me, is just a low voltage circuit on the back of the supply, so it's not mains. I think it's about 5 volts, and you just bridge these 2 contacts and that enables the power supply. So just literally hooked up a cable and a switch to that, nothing fancy at all. And that's just the front of the unit. I haven't put any labels on. It's just got the switch and the LED there. And again, I was quite happy because both of those came out of my junk box, which means, something comes out of it and I build, I have to put some more junk in my junk box. So it's a good excuse to go buy some more stuff. All right, so that's sort of the outside or the metalwork part of the case, but then I wanted to do a power distribution board as well, because it's obviously 60 amp supply and I wanted to supply just about everything in my shack. Excuse me. So, the power distribution board. So my preference is to have lots of outlets at the back of the power supply, and this just comes down to personal preference. There's no right or wrong. I find anyway it reduces clutter and also negates the need to have big heavy duty cable coming out of the power supply. So the requirements were for this board was to have it fused. I didn't want to run 60 amps. So I think I've got a 20 amp fuse in there at the moment, and or 10 amp, and that's fine for what I do. And I wanted to be able to stack these boards, so I just did a little bit of a sketch there of how I wanted to do it. So I could work out some dimensions. And I wanted to use Anderson power pole connectors out the back, because I think they're really good, and just about everything in my shack's got that. Now, I'm not sure whether everyone knows about it, but Anderson Power actually do these really neat right angle printed circuit board contacts, and they just go into standard housings. So the housings, I think, were just from J-Car, I bought them from. But you can just buy these pins, and I'll talk about where to get those in a minute. And they just go into the housings, and then you can solder these pins into the boards. So they work well. You can also secure these with these blue mounting wings. I think they call them genderless mounting wings. And I was talking about a gentleman earlier who's 3D printing them. I bought these. I'll give you some DigiKey part numbers in a bit. But that's how I secured them to the board. So the board was designed in Altium Designer, which used to be called Protel, because that's what I use at work and I had access to that. Been using it for a long time. And it's just exceptionally simple circuit, nothing complex at all, just a Anderson power pole connector there, that's what that symbol is. A fuse, and it's an automotive blade fuse socket I put on the board because they're readily available, easy to get, and they're small. And this is just for the LED, so resistor, and there's a JST, it's called a PA connector. They're very common, maybe not so much in amateur use because they're more low current, but in sort of hobbyist and remote control cars and things like that, they're used a lot, so I just use one of those. There's a printout of the circuit board on paper, not fiberglass yet. And again, I did that because there was not a good drawing which showed how the pins sort of located on the board with reference to the Anderson power pole sockets. So I tried to find a drawing, but I couldn't really find anything. So, excuse me, I worked it out, sort of reverse engineered and from the various data sheets and put it together, but I wasn't 100% confident. So I thought I'd just print it out again. Excuse me, it's a bit like the folded template. It's just a good way of checking. So I printed it out and made sure the outer dimensions of the paper matched the CAD, and then I thought, right, it's at the right scale. And then all I did was literally got a scalpel and put some slits in those grey areas. That's where the holes would be for the pins. And I just sat the Anderson power pole connectors in with the pins and just made sure it all lined up. And it turned out to be okay, but it gave me confidence before I ordered circuit boards. So I ordered the circuit boards from JLC PCB. Some of you may have heard of them. This is one of the more common low-cost Chinese PCB manufacturers. I loaded the Gerbers onto their website, which was really easy. And for those of you, you may not have heard the term Gerber before, so all CAD tools have their own, I guess, native format, which would be proprietary, but then they all output a format called Gerber, and PCB manufacturers use that to make the PCBs. So it's a industry standard format that they all understand, and it's sort of agnostic of the CAD package used to generate it. The cost was about $22.29 for 10 PCBs. It's just, I think it's 2 ounce copper I use, so it's thicker than normal PCB copper, and just 1.6 millimetre thick board. The shipping was $19.03, and that was express. You can get it cheaper. You could probably pay $2, $3, $4, but I wanted it quickly because I wanted to get it done. So the total cost was, you know, $41.32 or $4.13 per board. So it's pretty cheap. It's really good. There's the finished board, and you can see up the top there we've just got the fuse holder with the automotive blade fuse. There's the JST connector for the LED cable, and there's I'd use a surface mount resistor. It's an 0603 resistor, so that's what I had laying about, and all the Anderson power pole connectors with the blue mounting wings. And again, I just used M4 screws. They fitted through the holes in the mounting wings quite well. I thought I'd put a parts list of the bits in case anyone was interested in getting some of these. So the top one's just the blade fuse. There's a keystone part. The power pole contacts, they're not cheap. They're nearly $3 each, but you know, they work well, so it kind of is what it is. Blue mounting wings, and I also got some hex standoffs which I used to mount it. I'll show you that in a minute. I got all of that from DigiKey because I couldn't get some of the things anywhere else. Now DigiKey postage is about, it's free actually, sorry, if you order over about $50 or $60, and anyone can set up an account for personal use. You don't have to be a business. So I've got a personal account. And yeah, I had quite a few bits to get, so it added up over that. But I'd recommend if you need, you know, say you only need $10 or $15 worth of parts, maybe get in with a few friends or members of the club and just pull together so you can order your bits and, you know, avoid having to pay the postage. So the next step was to get the power distribution board all wired up in the enclosure. So the ultimate aim was to connect it up to the pads at the back of the power supply. So I just used some 12 AWG wire from JCar. Again, I just put the part numbers up there. I soldered the wires to the power distribution board first because I didn't want to put strain on the pads at the back of the power supply because it's designed to slot into a rack in a server. It's not really designed to have cables soldered to it. So I wanted to just be, mindful of that and make sure I wasn't going to rip tracks off boards. I stripped the wire and bent them into shape first and then soldered them. Now that's important with wire this thick because what happens is the solder wicks up the wire and you'll never bend it afterwards. Or not without, some serious tools and breaking the board. So make sure you bend it first and then solder. So there's the two cables there soldered into the power distribution board. And again, up at the other end, that's where they're going to solder onto the power supply, and again bent up first and soldered there, soldered on. And I also use a bit of actually flux on this because this power supply it's not super old, but it's old enough that the contacts that oxidise a little bit, so a bit of flux helped there. It's rework flux it's called. And then this cable here is the low voltage connection to the switch I showed earlier to the front panel. So at this point, I'd had all the board wired up and need to get it mounted in the base. So before I actually did a few of these steps, I drilled some holes in the base and tapped that as well. And this time I used M3 screws because I wanted to make this board fairly compact. You see those in the corner. And then the 4 10mm hex standoffs I'd got from DigiKey. Okay. And the intent is, at the moment I've only got one power distribution board in there, but I think I worked out I can fit about 4, so I'll just put more standoffs and stack them up when I eventually need them, and just add a few more connections to the back of the power supply. But for the moment, one's enough, so I've just left it at that. Now the back panel's still a bit of a work in progress. I wanted to use a power supply, so I hadn't quite finished that. But the intent there really is I hope to use maybe some clinch nuts into the back of the sheet metal and then just screw into those. You can buy tools relatively cheap now to press those clinch nuts into the aluminium, so I think I'll probably have a go at doing that. And then I can just screw the back panel on. I need to cut out some holes in the back panel for the power distribution board itself. So there, and then also for the IEC outlet and just a handle on the back of the power supply. So that's probably going to be the next step. Now, it's not easy trying to get all this jigged up and get it aligned, and I'm not going to pretend that it is, and this is perfect. Some adjustments were required, some hole widening had to be done, as you can see there. But I guess the message is, at least for me, don't let perfect get in the way good enough, just have a go. It's not perfect, it's not perfectly square, but I'm pretty happy with it. And I'm proud because I built it myself. So, I think that's a good thing, as with a lot of, homebrew ham stuff. One of the other lessons learnt was I think the jigsaw was really good for cutting sheet aluminium, so I'd highly recommend that, as long as you're careful and jig it up well. It works very well and is pretty easy. The other thing I found by the end of the bending was it's even though it's only 1mm aluminium, it's actually still pretty hard to bend. So it's more than secure enough, and I think if you could use 0.8, it would actually be a little bit easy to bend, but still have the rigidity. So if I did this again, I think I'd have a go with 0.8mm material, just make it a little bit easier to bend. Okay, so I guess acknowledgements, a huge thank you to my friend Lance, who's not a ham, but he's a tinkerer of other kinds and builds steam bikes and all kinds of exotic things. And yep, was super helpful, gave me a lot of guidance and helped bend it up and helped fold the lid. And I think one of the funniest things was when I took the thing round to him, all finished, he said, "Richard, that looks great, but we can't have scratches on that aluminium." And he actually got out his chrome bumper bar polish and just gave it a touch up on the lid and the sides, and it actually, and that brought it up really well. So Just I guess a thank you and shout out to him. I think, as with a lot of these projects, it's not a one-person job. You get some help, some guidance from people who have more knowledge than you, and you end up with a better project in the end. So, thanks to Lance. And that was it. If anyone had any questions.
It's on. So, Richard, a couple of things. First of all, just for the members' benefit, the club does have a sheet metal bender downstairs, which will do up to 2 millimetres or probably 1.5 millimetre thick aluminium.
Okay.
So, anyone wants to bend things, just a matter of organising yourself.
Yep.
The question, the wires that you're running from the power supply to the power distribution board.
Yep.
What's the current capacity of those wires in relation to the 60 amp power supply?
Yep.
And also the thickness of the copper on the circuit board.
Yep.
What sort of current can it take?
Well, it must be able to take 60 amps, but it might take that by a combination of all the contacts, so maybe each one won't be able to take it. It's a good question about the cable, and it's a lot less than 60, as I think someone said, about 30, so something like that.
30 amps.
Yep, so you're right. I mean, there's a chance that if something breaks and then it hits the case, it'll still short, but I thought about that, and I thought the probability is pretty low, and the fuse in there is a lot less than 60, so I kind of just lived with that, rather than putting really thick gauge copper, which probably would have ripped the tracks off the board.
Okay.
So, good question. I think that is a good point. The fan does make a noise, and it's on all the time unless I pull the cord out because I've only got the low voltage shut off.
A quick comment from me on the fan. What I've actually done with 20 amp power supply was just hack it up, pull the fan out, and replace it with a silent computer fan, and that made it a whole lot quieter. And then, we've got a question from Zoom here from Eric. Does the main power supply have any over voltage protection, or is that not likely to happen?
I don't know, to be honest. That's a good question. I guess being a HP server thing, I would hazard a guess that it should have something decent, but I don't know. Good question.
And then there's another comment there from David. He says, great job, Richard. I found in a similar project that fixed Anderson connections on your power supply tend to snap using heavy gauge cable. I found it preferable to use a short tail, provided the flexibility to protect the power supply connections.
Yep.
But I think with the board, let me go and, because I've got the power to do that. It's a pretty solid board there. And I think that is, since it's not just soldered in, but also has those spacers that are screwed in, that looks pretty solid to me.
Yeah, I do have, the other thing is I do have the Gerber files available, and I have a few spare boards, so if anyone would like to make one, I'm happy to give them the files, or, there's a couple of spare boards. Happy to sell those at what they cost me.
Richard, on behalf of those assembled here, thank you very much for a most interesting and well presented discussion on the power supply. And I think you're right. I think if you haven't got confidence in HP, you shouldn't be using it. It's as simple as that. So, people in the room, you'd like to join me in a round of appreciation for Richard. Thank you. You're welcome to come up. Those online, thank you very much for attendance again tonight. Look forward to seeing you in the room sometime. Thank you. I call the meeting closed at this stage. Thank you.